On free response questions, if it asks you for the equation of a tangent line, and you will see at least one free response question that asks for the equation of a tangent line, unless they really throw curveballs in there this year on the exam. You'll probably see more than one. Equation of a tangent line, just leave it. Okay? Don't do anything else to this. You just plug it in and you leave it. Because you could distribute y equals 4x minus 24 minus 2. And then you could say y equals 4x minus 26. You could do that and get it in point slope form. Not point slope. Slope-intercept form, right? Y equals mx plus b. But you might mess up. You might say that negative 24 minus 2 is negative 22. And if you do that, silly mistake, then you do not get the answer point. Whereas if you had just left it like this, then you would have gotten the point. So the main reason we use point slope form in calculus, but I did not teach it in any class before this, is just because for the AP exam, you're less likely to make a mistake if you're using this. Because you can just put it in this form and leave it. You don't have to simplify it. So, free response, you are going to leave it this way. Now, there's a chance if it's multiple choice, you may have to actually simplify it so that you can actually get that, like y-intercept or something from that. But if all they ask for is the equation of the tangent line, we're going to leave it. And the questions we're about to do are going to ask for tangent lines. So we're going to need this. That's why it's here. All right, so we are supposed to write the equation of the line tangent to f of x equals the square root of x minus 2 at x equals 3. Okay, so if we want to write the equation of a tangent line, we need two things. Think about that formula that we just did. What two things did I have to use this formula? A slope and a point, right? It's in the name of the formula that you got there. You have to have a slope and a point. So anytime you see equation of the tangent line, you need to be thinking of these two things that you need. First thing that you need, or order doesn't matter here, but I'm going to number, is you need a slope. How do we find a slope of a tangent line? What can give us slope of a tangent line? Derivative at the point. So we need the derivative at the point. So that would be f prime of 3 is how we would label it. For this particular problem, it would be 3. Okay. We also need a point on the line. Okay. How do we find the point? Specifically, we want that like point of tangency, the place where it touches. Just plug in 3. So we could just find f of 3. Right? And then I'm going to put third step, write the equation of the line. So we will do lots of tangent line problems. Tangent lines are basically the main idea of the first half of calculus, right? Limits are the basis of everything. We just finished our limit unit, right? The limits are how we reason through all of calculus, basically. But beyond that, what we're going to learn this semester is going to be split into two other major topics. We got derivatives, and derivatives are slope of the tangent line. And we're going to learn how to do lots of different things with those derivatives, but it's the main focus. And then we've got integrals, which is going to be something different that we'll do. They'll come mostly like around Christmas and after. Slope of the tangent line is a really big deal. We've got to be able to do this correctly. Right now, the only way we know to find a derivative is to do limit definition of a derivative. Okay, so we have options on this, and I'm going to do a few of these examples using the limit definition of a derivative at a point, and I'm going to do a couple using the limit definition that we used last night on the homework. Okay, so if we remember those, limit definition of derivative here at a point, that was our limit as x approaches a of f of x minus f of a over x minus a. And then just the general form is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So these two things we need to have memorized. Really, on these problems, I think for most everything we're going to do, you could use either one of these because we'll be looking at a point to do a tangent line. I'm going to do some both ways just so you've seen them done both ways, but you could just pick one to do here. So in this case, I need a point, a slope, and equation of the tangent line. So if I want to find, I'm going to start with the point because it's easy. So my point, I just want to find f of 3. It is very important that you label what you are doing here. It is not that important that you tell me you're doing the square root of 3 minus 2, which is square root of 1, which equals 1. Okay? It is not that important that you write this middle stuff right here. If all you write is f of 3 equals 1, that's okay. Because at this level, they expect you to be able to plug 3 into that in your head and get the answer. So they're not looking for you to write that work out. But if you don't put f of 3, even if you have the other work, that's going to be a problem. Because you're not showing what 1 is. You're just doing scratch work that you have not told them what it is. Okay? So it's really important that you label it. You have to put f of 3. That is essential. So that's telling us there that our point is at x-coordinate 3, y-coordinate 1. Again, not essential that you write that down. The only thing that is absolutely essential here is that you say f of 3 equals 1. It's okay if you don't write out the point 3, 1. It's okay if you don't show your work to get there, but you got to show f of 3 equals 1 because that shows the grader that you are plugging 3 into the function, you got 1 out, and they expect you to understand that means the point 3, 1 is on the graph. Okay? We good here? Alright, so now we need the slope. And I think for this one, let's do limit definition at a point. So I'm going to use this limit as x approaches a of f of x minus f of a over x minus a. Although I could use the other, it really doesn't matter. I'm also going to label this. I'm going to label it f prime of 3. Okay, that means the derivative of f at 3. And so when I do that, I'm going to do the limit as x approaches 3 of f of x is just square root of x minus 2 minus f of a. What is f of a? Is 1. We just found it, right? That's another good reason for doing the point first because you already have that value. And then we'll have x minus 3 here. Okay. We've got a square root. We're going to have to rationalize. We're going to put these in parentheses here. And then we're going to put this in parentheses when we do square root of x minus 2 plus 1. We're going to multiply that on top and bottom. So that will give us the limit as x approaches 3 of, we'll get x minus 2 minus 1 over, make sure you've got parentheses here. If you don't, it's incorrect. Okay, here. It is going to be perfectly fine if you say, oh, x minus 2 minus 1. That's just x minus 3, right? And it's going to cancel with this x minus 3 right here. They are not grading whenever they grade these AP exams for those intermediate steps, right? If you're doing stuff like that in your head, it's not a big deal. The things that are a big deal is making sure you hold on to your limit notation until it's the proper time to drop it, making sure you label everything to very clearly show that you understand what you are doing and you're not just like, you know, doing crazy stuff that kind of like whenever you get, when you were like in elementary school, if you ever got a question you really didn't know it had two numbers, you just like add them together, see if it was an answer choice, subtract them, see if it was an answer choice, multiply, see if it's an answer choice, divide, see if it's an answer choice. Some of them, Math 1 students, sometimes that's still their strategy. They want to make sure you know what you're doing. And you do that by clearly labeling stuff. So, now I still have limit notation because I have not plugged in my 3 yet. At this point, I'm plugging in the 3, so I can drop limit notation. What is square root of 1? Is 1. So we're going to get 1/2. Oh wait, I almost circled that like it was my final answer. Is that my final answer? It feels like it. What did the question ask us for? The equation of the tangent line, right? So what we just found, this is my slope, right? It's so much work that you feel like you are done whenever you get done with it. But that's just my slope. But now I have my slope. I have my point. So I'm going, I'd love to be an AP grader, and maybe they'll pick me this year. I don't think it's like on merit. Like, I think if you graded before and done a good job, like, they'll call you back. But, like, I think it's kind of random whether or not they pick you. I'm hoping that my application is just not, like, bad or something. They're not picking me. But I want to be an AP grader so that I know for sure, like, I don't think you have to label this equation of tangent line at x equals 3, and you're just going to say y equals 1/2 x minus 3 plus 1. And you're going to leave it like that. That's going to be your answer. Leave it in that point slope form. I don't think you have to label it to get that answer right, but just look how nice it looks if you do label it. Like, there's no question that you understand that is your answer for this, and you know what that answer is. So, I would still encourage it here. And as you're doing your homework for this, I would encourage you, you can't use Desmos on the test, but it's always good to kind of get like a picture in your head of what's happening here. And it'll let you know if you did it right. If you graph your function, graph your equation, you could even graph the point, 3, 1. Graph the point. Graph the equation of your tangent line, y equals 1/2 x minus 3 plus 1. And you should see there on the picture, there at 3, point on the graph, it touches the graph at just that single point. It looks like everything is good here. So that can, like, as you do your work, which a lot of them will be odd, you could check the back of the book as well, but this kind of helps you, like, picture what's happening also. I mean, really, you can do this. This stuff is usually not on Calculator Active, but you can graph it in your calculator as well. Calculator just doesn't give you as easy of a graph. Can't graph that point, but you can graph these two easily. Okay, question on tangent line. It's basically what we've been doing. I'm also going to tell you we'll keep doing these problems. They will get easier because eventually we won't have to do this limit stuff for our derivative. We'll be able to do that more quickly because we won't have to do the limit stuff. But right now it's all we've got. So we've got to do this way. Let's try another problem. And this one's a little bit different because it says the graph above shows f of x and the table above gives select values of the derivative of f. Write the equation of the line tangent to the graph of f at x equals -1. Then graph the tangent line on the graph above. So this problem really is going to be very little work, especially compared to what we just did on the last problem. But it's the same pieces of information that we need to know. We need to know the point, we need to know the slope, we need to put that into the equation of a line. So, oh, excuse me. Let's start with the point. And if this is free response, and a lot of times you may see this stuff free response, where there's not really a lot of work that you got to show. You must label these to show what you've got, even though you're not like doing work for it, right? So when we're finding the point, we're doing f of, our x value here is -1. So f of -1. And I'm going to do f of -1 equals, and if I look at my graph, -1, looks like we're dealing with this point right here. What's the y coordinate of that? -6. So my point is -1, -6. You've got to write down where you do f of -1 equals -6. Okay? You don't have to explain it further, but you got to write that part down. Then we need our slope. And for our slope, we need to look at the derivative, right? So they gave us a table with the derivative. We want to find f prime of -1. Right, the derivative at that point. What is it? It is 4. Right, because we're just reading it off of this table. Whenever x is -1, f prime is 4. So 4, that is my slope. So my equation of my tangent at x equals -1 is going to be y equals 4 times x plus 1 minus 6. And so, if we want to graph that, it's just, we know it goes, we don't even have to like simplify this. We know it goes through the point -1, 6. We know it has, this line has a slope of 4, so if we go up 4 over 1, or down 4, left 1, we will get that line right there that does appear to be a tangent at that point. These are on the AP exam sometimes. Just like this. No tricks about it, no like work to do. Sometimes they're on the AP exam. So I always like it when I see these problems. I think they're pretty straightforward. Okay, questions? Let's see. Okay, we're going to do one of these just in case it ever shows up. I'm not sure if it's going to, but we're going to do one. It's not much different than tangent line. So we're going to do one just in case it shows up, because some of the older AP questions ask about normal lines. I do not think that they are going to ask it on modern tests. So I don't think you'll see this on the AP exam. I don't plan on giving it to you on the test, on any tests or quizzes. But where you may see it, it could possibly show up in some free response questions I give you for like the free response quiz. And you've seen it in case you run into it somewhere down the line. I know that Jack Zamudio's taking Calc 2 at Chapel Hill, and he said there's like some stuff that he's ran into that we didn't really do, that the professor's kind of like expecting them to know. He didn't say this in particular, but like it won't hurt us to do one of these, even if we're not going to see it on the exam, and it's pretty similar to our tangent line problem. And that way we've at least can say we've done it. Maybe you'll remember it, or it'll be vaguely familiar if you get to see it down the line. So a normal line is the line perpendicular to a tangent line at the point of tangency. So if I go back to this last graph right here, if we had a normal line, it would look something like this, right? This is what the question was asking for. That's your tangent. The normal line is perpendicular to that. So steps are going to be almost the same. For this problem, just to give us, well, let's see, do I want to do that here? Oh, we've got to do it here. Let's use limit definition at a point again for this one. Because we're going to have to do x plus h on the next one. So, at a point, I'm going to find my point first. And that makes it a little bit easier while we're having to do this limit definition, because it'll find that f of a for us. So, we're just going to do f of 3, which will give us 1 over 3 plus 2, which is 1/5. So we know our point is 3 1/5. Our slope is going to be almost like we have done before. Our slope, we're going to use the derivative to find the slope at that point, but the derivative gives us the slope of the tangent line. So once we get that, what do we have to do for a normal line? If it's perpendicular, what do we do? Kind of the opposite. What have you got to do to the number? Like if we have 2/3, what have we got to do to it? Almost. You're going to flip it and make it negative. So it's the opposite reciprocal. Flip and change the sign for perpendicular lines. So once we get our answer, we need to flip it and change the sign to get the normal line slope. But the first part is just going to be like we were doing on the last one. So we are looking for f prime of 3. We're going to label this f prime of 3 to show we know this is the derivative at 3. And the derivative gives us the slope of the tangent line. And then we're going to do the limit as x approaches 3 of, we'll have 1 over x plus 2, that's our f of x part, minus f of a, which is our 1/5 that we just found in the step above, over x minus 3. And so you got a couple options on how you solve this. It is up to you. You can get common denominators in this numerator, and then you can flip and multiply, or we could multiply top and bottom here by something. I think I'm going to, because we've got different denominators, I think I'm going to do this. I'm going to multiply this one by 5. And I'm going to multiply this one by x plus 2. So I'm only dealing with that numerator to get those together. So that is going to give me 5 minus x minus 2. Be really careful right there because that negative has to be distributed to both of those. And it is really easy to lose that negative. Let's see. And that is our numerator, but then that's over 5 times x plus 2. And then it's still over x minus 3. All right, here. Okay, we are going to simplify, and I'm going to go ahead, I'm going to put this over 1, and we are going to go ahead and do the flip and multiply just so I don't have to do quite as much here. So I've got to do limit as x approaches 3 of 3 minus x over 5 times x plus 2 times x minus, I'm sorry, I didn't flip, did I? 1 over x minus 3. Oh, does anything cancel? If I take a negative out of this term right here, then I'll have x minus 3 that can cancel. So I will do the limit as x approaches 3 of negative x minus 3. That'll flip that around. And now the x minus 3's can cancel. So we're doing limit as x approaches 3 of negative 1 over 5 times x plus 2. And once we plug in our 3, we can drop limit notation. 5 times 3 plus 2 is negative 1 over 5 times 5, which will give us 25. So negative 1/25. Now, that is f prime of 3 is negative 1 over 25. That's not what we need. That gives us, this is slope of tangent line, right? This question asks us for a normal line. So if we want our slope of the normal line, what have we got to do? What? Good. I like the fancy words you used the first time, though. Opposite reciprocal makes you sound fancy, right? Whenever you go to college and you have a Russian professor, he's probably going to say fancy words like opposite reciprocal instead of this flip and change the sign. But it is flipping and changing the sign, so we're just going to get 25 for that slope. All right, so we're using 25. Our point way back up here was 3/1/5. So slope, I mean not slope, equation of the normal line at x equals 3 is going to be y equals 25 times x minus 3 plus 1/5. Leave it. Do not try to simplify it, especially whenever you see fractions like that, right? Because your y-intercept's going to be a fraction. You're going to mess it up, and they don't care if you simplify on that. So just leave it like it is. So if you see a normal line, that one extra step where we flip and change the sign, use that opposite reciprocal is the only difference in these problems. Okay, questions here? All right, we've got, I think one more. Just one, maybe two. One. All right. Okay, we need to find the equation of the line that is tangent to the graph of f of x equals x squared plus 4x and parallel to 2x plus y equals 8. Now, this is the question that will get you thinking. It's the equation of a tangent line, right? So we know we need a point, we need a slope. I need you to think of, well, what's missing? What's been on the other problems that we don't have on this problem? What? The point. The other ones have said, like, at x equals 2, or at x equals 3, right? This one does not say that. So we're going to have to find the point first. We need to know what point this is at before we can actually do anything with this. How in the world are we going to do that? Okay, we are going to have to use our x plus h formula, which will give me the derivative at any point, right? Then, let's think about this. If I have a tangent line that's parallel to this line, do I know, if lines are parallel, what do I know about their slopes? They have the same slope. So that's telling me that the slope of the tangent line I'm looking for has to have the same slope as this line right here. What is the slope of that line right there? It's -2, because I'd have to move that 2x to the other side. It's got to be in y equals mx plus b form for me to tell. So the slope of this line, -2. So I know the f prime of whatever point I'm looking for, it's got to be -2. But I don't know what that slope is, right? I don't know what that point is. I know what the slope is going to be, but I don't know the point. So on this problem, I am going to have to use that general form for the derivative because I do not know what the point is. I can't plug in a point, right? So that general form is the limit as h approaches 0 of f of x plus h minus f of x over h. It's the one we were using last night. So for this problem, that is going to be the limit as h. Actually, I'm gonna also, let's label this. I'm gonna move down here, give myself some room. F prime of x. We've been doing like f prime of 2, f prime of 3, f prime of -1, something like that. This is the general form, so we haven't plugged the point in. So we say f prime of x, and then we'll do limit as h approaches 0. And we'll have f of x plus h, so that will be x plus h squared plus 4 times x plus h. Then I have to subtract f of x, so x squared plus 4x. Make sure you got parentheses around that because you're going to need to distribute that negative over h. Okay, so that is going to be my limit as h approaches 0 of x squared plus 2xh plus h squared plus 4x plus 4h minus x squared minus 4x all over h. This seems easy compared to what we had to do on the warm-up now. X squared is going to cancel. 4x's will cancel if we factor out a h here. We've got 2x plus h plus 4 over h. All right, here. H's cancel. We can plug in 0 for our h, so 2x plus 0 plus 4 is just going to give us 2x plus 4. So f prime of x equals 2x plus 4. Okay, so we found derivative. All right, where can we go from here? What? This has to equal negative 2 because f prime of x, this is the slope of the tangent, right? That's what it means to find a derivative. It means you're finding the slope of the tangent. So, we know that that needs to equal negative 2 because it needs to be parallel to that other line that they gave us. So we can say 2x plus 4 equals negative 2. And now this is a very simple equation for us to solve. We are going to subtract 4. 2x equals negative 6. We will divide by 2. X equals negative 3. There's part of our point, right? That's our x coordinates. So we're almost there at this point. What else do we need to find? We need the y coordinate. How do I find the y coordinate that goes with this? We're going to plug the negative 3 in. Where do we plug it in? No, it will not work to put it in the parallel line. Are we looking for slope? We already know slope. What's our slope? Well, it is 2x plus 4. Specifically, though, we know at this point we want it to be negative 2. Which, if we watch what happens if you plug it in here, if you do f prime of negative 3, that gives you 2 times negative 3 plus 4, which is negative 6 plus 4, which is negative 2. That is your slope of the tangent, right? The derivative gives you the slope. We already had it because we already knew it was negative 2. You could do this step, but it is unnecessary, right? You don't have to do that because we already had it before. So how do I find the y coordinate on the point? F of negative 3. I plug it into f of x to find that point. So I'm going to do f of negative 3, which is going to be negative 3 squared, what is it, plus 4x, yeah, plus 4 times negative 3. That's going to give us 9 minus 12, which will give us also negative 3. So my y coordinate is negative 3. I've got negative 3, negative 3. Make sure you're labeling everything. This is your point. Your slope is negative 2. So your equation of your tangent line is going to be y equals negative 2 x plus 3 minus 3. So that would be our final answer on this. Let's look at this in Desmos just to make sure we understand what we're doing here. So our function was x squared plus 4x. We got this. And so we had this line that they gave us 2x plus y equals 8. Oops, 8. So we wanted a tangent line parallel to that, but obviously that's not our tangent line, right? So if we check our answer, hopefully it's going to look good. Y equals -2 times x plus 3 minus 3. You can see the tangent line parallel to that black line right there is our answer. So it looks like we've done a good job there. Kind of. They almost don't look parallel. They are, though, because they have the same slope, but almost don't look parallel.
That question was just asked us to find the specific point where that tangent line is parallel to the 2x plus y.
Yes, and then write the equation for that tangent line at that point. Yeah. Yeah, but the big part of that problem is figuring out where that point is at. Okay. Questions? All right. Your assignment for tonight is going to be these 6 questions here. Let's see. The first ones are going to ask for equation of a tangent line. 34 and 36 are going to be like the last problem that we just did. So, and on the first 4, you can use the limit definition at a point, or if you just would rather, you can use the f of x plus h one that we did, but you will need to plug in your number if you do that. So, oh look, we finished with time for y'all to do your work.